Alright, we come to the revision for the variable forces, okay, or maybe you can call variable acceleration for the further mechanics, right? So these chapters, we will use, okay, we will use the skill from the differential equation from pure math 3. So, so this will involve a lot of calculus in the pure math 3, as for example, differentiation, integration, right? So maybe partial fraction also, or maybe integration by part, and these chapters we will use the, let's say we will go to the basic principle of the differentiation, right? I remember v equal to ds dt, right? And we know that a will be equal to dv dt. Or maybe we can do the second derivative of the ds dt. Right. So by using these two formula, we're going to solve the problem in these chapters. So you need to choose that which you're going to use and which will be suitable for you to use in these chapters. Okay. So let me remove this part first. And we know that a equal to dv dt. Okay, and this is equal to, if you use the chain rules, this is equal to dv ds multiply ds dt. And if we simplify, we know that ds dt is equal to v, and dv ds we keep. So the s there will be the displacement. Sometimes the question will change to dvdx, right? So it's the same, right? So you may use these two possible solution differential equation to solve the following problem. So you need to choose, depends on the question requirement of the question. If the question require you, let's say, to put v in terms of t, so definitely you will use dv dt. If the question asks you to solve, if you need you to put v in terms of s, so you may use dv ds to solve the problem, right? So there are two differential equation for the a. So let's see the question one, how we use it for question one. Okay, thanks. Now we proceed to question one. Okay, question one. Okay, a particle is moving with a constant acceleration a at time t equals 0 and has a velocity of u. Okay, for here, u is a constant and is at the point O after time t second. It has a move in the distance sm and now moving with a velocity of v. The quantities s, v are variables, also variable. So writing dv dt equal to a, integrate both sides to get the first formula. So red formula, I mean the constant acceleration formula. Okay, so for this we will use v dv dt equal to a. So we integrate two sides. Right. So like what you've done in the differential equation, separate them to two sides, and If you rearrange, if you continue, sorry, you'll get v at one side. Another side, assuming that this is a constant acceleration, as mentioned in the question, so you have a v equal to at plus c, right? And apply the initial condition t equal to 0, v equal to u. Okay, so you get the c equal to u, right? And if you rearrange, you will get v equal to u plus at, right? Oh, this is the formula that you have learned before, right? E equal to u plus at. So this one for question A. Okay, for 1B, question say, okay, ds dt is equal to v, right? And same things, separate them to two sides. So integrate ds, and you have v dt, so that you have s equal to integrate of, use the output from the previous part, u plus at dt. Okay, and you continue, you will have a ut plus at square over 2 plus c. Okay, and if you continue to put the initial condition t equal to 0, s equal to 0, right, you will get c equal to 0. Okay, so at the end you will get s equal to ut plus half at square, right? So you'll get another constant acceleration formula for part B, right? So this one for question 1.